Dr. Chuck the Science Schmuck.
Synchronize. Now, if you're anything like me, you think a lot about a few primary topics. And one of the biggest one is knives. Constantly thinking about knives. Specifically making knives. But there's a problem. The main thing being, I don't have a forge. Generally, to work with metal, you need a forge. I haven't managed to construct one yet. So working with metal is hard. I have to use torches or substitutions or not make good quality blades. But a thought occurred to me the other day as I was thinking. I don't know where I was thinking or why I was thinking, but a thought came to me. Why not plastic? Specifically, in this case, I have epoxy. This is some very old, easy cast. It's usually used for making clear casts. I was originally using it to preserve some specimens, but it's very old, and you'll notice that the hardener has turned brown. So this is pretty well past its expiration date and really can't be used for much. I've had it for years, haven't really used it for anything. So I thought, why not try to use it and make myself an epoxy knife? And that sounds a little absurd, but I don't think it is. Plastic knives can exist. I mean, anyone who has ever eaten at like a school cafeteria has probably had a plastic knife to cut their food because they don't trust you with the metal ones. The thing is, plastic can be really sharp. It's just a question of if it can hold an edge. So, what is epoxy? Epoxy is a pretty well thermostable plastic made by mixing resin. Resin will go in this cup once we start the party, and hardener. So you gotta mix them like that, combine the two, and it will undergo a chemical reaction that induces polymerization and hardens. The problem being that when you combine these two in the wrong proportions, as I have every single time, it doesn't come out right. So we're gonna try to do it correctly this time, with expired products, in a product that nobody has ever actually tried to make before. That probably won't work, but that's the fun of it. None of the stuff I do ever works. Who even cares? So, the first step in this I've already done. I need a mold to make the knife. You could just, if you had enough epoxy, make a brick and cut the epoxy to the right size. I don't have a lot of it. So what do I have here? Mold. They say they broke the mold when they made me. Fortunately, it grew over the top of the vat real quick after that. You'll note that it's made of cardboard from old Amazon boxes that I happen to have lying around, stuck together with a ton of Elmer's glue, then compressed so that it makes something similar to a board. Then I took a knife and just poked it and cut through until I had a knife shape. You may notice blueness associated with the shape. Unless you're colorblind, then you may not notice blueness, but you probably see a color contrast. Maybe. I mean, this shade of blue. Somebody's driving a really fast car by, but for a second it sounded almost musical. Do note that if you have a car that has an engine, be sure, if you're going to make it loud, that it's a very low-pitched thrumming engine. When it sounds like you are riding a weed whacker, it does not sound good. We laugh at you. But anyway, blue tape, painter's tape, is pretty standard stuff. Put it around the edge because corrugated cardboard is corrugated, it's full of holes. So that keeps the epoxy from escaping out into the cardboard. Then I backed it with tape and put tape on it. Now I could have gone through this. I kind of get this effect that I do a lot of stuff off camera in these videos, but it's because you don't come here to look at me. You come here for like a 15-minute episode of something useful, and I give you a 45-minute episode of something that's not useful at all, because it's my channel and I can do what I want. Although I am interested in hearing criticisms and suggestions, which you can leave in the comments if anyone actually comments. I do like hearing from people. It kind of gets lonely being in the videos all alone forever. But anyway, notice it's knife shaped. The knife will have to be shaped more so than this and given a point and filed down and sharpened after the epoxy is made. A theoretical thing to note, I've worked with epoxy for a long time. Years, decades. When I tried to go to college, I didn't do well in college, but I was in a club where a lot of what we did was epoxy. So I've done a lot of epoxy. Epoxy itself is very hard, but well, it's not hard in this state, it's liquid in this state, but it's not that hard. Epoxy as a media for producing a product requires filler. Epoxy is basically real strong glue, if you've ever watched the Blues Brothers, and you can make something out of hardened glue, but it'll be brittle and fragile. We made vehicles, we didn't make them out of solid epoxy, we made them out of other material. So for long pieces, you use what's called, well, there's a duck laughing at me from outside, but it's probably a goose, and I don't want to mess with a goose. Fabric, we would impregnate fabric with epoxy, and then it gets hard as a straight material, which was light and durable. I have this piece of fabric, which I can do with that. The other aspect is filler. When you want epoxy to be big and fill a hole, you add filler. The epoxy acts like a glue holding the particle. Filler. It's not a goose, it's a person. Or a goose getting punched. I don't even know what I'm hearing. Regardless, epoxy acts as a glue that holds particles of filler together, which produces relatively light, hard materials that are good for filling holes. If you've ever seen a car that has Bondo, Bondo is not exactly epoxy, but it's similar. It's the basic premise. You mix it up into this slurry, fill a hole, and it provides stability. What I have are these two aspects. One is carbon. You may remember this carbon from me trying to make makeup out of it, and from me using it in resin, although that might happen in the future because I film a lot of these videos at the same time. So where did this carbon come from? Well, when I generate lye, it has charcoal in it, just inherently, because it comes from a wood stove. I melt it down. No, carbon doesn't melt. How do I make this? How did I make this? Drawing a blank. I rinse it. Then I heat it until it's dry, not in the microwave. It explodes violently. Learned that the hard way. Then mortar and pestle it down to a fine powder. That will serve as a porous catalyst for the epoxy to attach to that will act as the filler, making the blade lighter, but also stronger. Adding hardness is a little harder. We need to add something into the filler that is hard. Charcoal is not very hard. That's why I have this. A jar of purified depotlith. Now you may be asking, you dirty schmuck, what is depotlith? Well, if you've ever been to a Home Depot and you walk around, so many birds, but if you ever go to a Home Depot and walk around and you start touching things, you'll notice that everything is covered in this very fine grit. And nobody likes that grit. In fact, a lot of people hate it, but most people aren't conscious of it. I have dubbed that word depotlith, from depot for Home Depot, lith meaning stone. It's similar actually in consistency to supposedly the material that's on the surface of the moon. This would look very similar to what moon dust looks like. It's just powdered gray rock. But in this case, it's actually produced from concrete. Fine particles in concrete, which Home Depot usually has a lot of, get dispersed into the atmosphere and come down, making a very gritty dust. This was actually made from the banana project. If you recall, I was making calcium acetate. I dissolved the calcium out of concrete and then filtered it to produce calcium acetate. This was what was left over in my filters. Very fine silica dust with a lot of calcium acetate still attached to it. I didn't rinse it or anything. So silica is made of rock. It's very tiny rocks, really. And because of that, it's very hard. Hardness of 7, that's harder than steel. So the idea would be that this permeating the blade gives it a sturdier aspect. What do I mean by sturdier aspect? I mean that will give it the hardness to cut through things, in theory. So the first thing to do when I'm preparing this is to read the instructions. But I don't read so good. It's one reason I didn't do well in college. So we're not going to bother with that. However, I do... what does this even say? Enjuaguese muy bien con agua por 15 minutos y busque atención médica. Piel, lave inmediatamente con agua y jabón. Luego, I can't read that word. muy bien con agua. No use solvents ni alcohol para remover el producto de la piel. I mean, I know what that means because I'm pretty good at reading Spanish, but I can't read it. So, first thing I want to add is the resin solution. To do that, I need to make a mark. This is the important part. Don't ever shake a Sharpie, it'll explode in your hand. Equal amounts of both. Either a dust or a very small spider just flew into my eye. These cups are not exactly ideal because they're too curvy. So there's like ridges inside and they're not even. I mean, it would be better to use a cup that has a defined volume, but these are the cups I've got. That'll use up most of it. I kind of need to. Part of the idea of this channel is that I have a ton of resources that I've accumulated through the years, but I don't like moving 70 pounds of resources. 70, 700, 7,000, I don't know. So I'm using up my resources so that I'll have nothing. Not quite a smell to it. You're going to want to put your googles on. Not quite a smell to it at all. Kind of plasticky. So you can see I have a cup. Well, I think that was pretty obvious. And I'm going to pour this stuff in it. And it's pretty viscous, probably because it's pretty old. Very viscous. I want to stick my finger in it really bad. But that's a bad idea, and I shouldn't do that. So I'm going to start with not too much of it, because I don't want to waste the entire thing in case I need to redo part. So then, in the other cup, I'm going to have to eyeball this because measuring is for nubs. Tiny little nubs. This stuff is actually carcinogenic, so I shouldn't breathe it. But it smells very similar to potent dirt. As you can see, it's clearly expired. This color is usually caused by peroxidation in organic solutions, so it's basically pulling in oxygen and burning itself out. One thing you should know that they always taught me at work is if you see an organic solution that is this color, basically run. A lot of solutions, especially anything containing ether that develops this color, is forming peroxides with itself. Peroxides are oxygen drawn from the air, formed on organic molecules, which, if you're familiar with chemistry, is explosive. Very, very, very explosive. So, a lot of times you can get these ancient bottles of like somebody left this in from the 70s and it's ether that's now all yellow and almost even this color. That's explosive. I mean, don't ask what I actually do for a job. It's not this. So, we shall begin the reaction by combining the two. Definitely people talking outside, but I don't know what they're talking about. Probably don't need to know what they're talking about. It's their stuff. They can probably hear me, though, which is a little weird. Oh, I already got it on me, but you gotta know you're gonna get it on you at some point. You do not work with epoxy without getting sticky. There's something else I did at work the other day. I got incredibly sticky. Like, unbelievably sticky. You could not imagine how sticky I was. But then again, that's my job. I'm not allowed to talk about. Like, actually, they give you rules and say, don't talk about this stuff. So, you can see I have a stick found down on the ground. They come out of trees. This will require substantial mixing. That is the mistake. The number one mistake that I personally make with epoxy is not mixing enough. It's viscous, it's thick, really, really thick, but you have to mix it. This stuff shouldn't harden immediately. There is epoxy that'll harden in like a minute. This is not it. This epoxy needs to be mixed. Yes, so one important aspect that I like to do is mix together the two, or switch them between the original containers, so that all of the extra hardener in one gets mixed with the resin in the other, and all of the extra resin gets mixed with the hardener. Unfortunately, it's very gooey, so that's not a very quick process like you would see with a smaller... I really need to clean this table. There's so much stuff on it. I probably need to burn it. I probably need to sand it, to be frank. I have to wash it, just hit it with the hose until it's clean, and then sand down the top to get everything off. Now, you may notice there are air bubbles in the epoxy. That's bound to happen. Oh, I just got stickier. Why am I always sticky? Every single second, every single day, no matter where I put my hand. Now, I'm in the movie theater and I touch the seat in front of me. Sticky. Stick my hand under a bus seat. Sticky. Stick my hand through the couch cushions. Not my couch. My couch is very unsticky. It's, you know, the couches you find on the side of the street looking for coins and cats and stuff. So, do I have pliers? Do I have gloves? No. So the first thing I need to do is dip this piece of canvas in there and get it fully wet. Why? This will be the backbone of the blade. Weirdly enough, it's canvas, but remember, epoxy is brittle. This has very high tensile strength, so force on it will just pull on this and will prevent the epoxy from taking the force. It could go all the way down to the handle. That'll kind of be a potential weak point, but I don't expect to be using this like in actual combat. It'll just be for basic cutting of, you know, non-person things. I actually, because of the first law of robotics, I'm not actually able to hurt a person. Also, do not like being sticky, but sometimes you have to get sticky in the name of science. Yeah, I'm just sticking my fingers in the epoxy. That is not professional. Hold on a second. I'm going to let that sit. It won't dry very quickly. So that's going to wait. I have to go wash this off my hands before I corrode it. The irony being that that portion that I read, for those of you who are not familiar with Spanish, was a paragraph on what to do when you get this on your hands. You're supposed to wash it off with plenty of water and soap. Hopefully. I didn't actually have very good comprehension of what I was reading. I just sort of was like, there's a fly trying to get in my epoxy. That's the worst place for a fly, other than in my eye. They do go in your eyes. I've had a fly in my eye before, like under the lid. I had to squeeze it out. So, next ingredient, carbon. Carbon is highly hydrophobic, so this should mix pretty well. Add your carbon. It's like, you remember back when they were marketing yogurt that had, well, they probably still make it, yogurt that had that stuff that you combine with it. So like there was a special pouch inside full of, I don't know, walnuts or fruit or something. I mean, I was more of a fruit on the bottom kind of guy, so you get the yogurt that looks super gross and then you have to mix it to get the fruit, because yogurt, plain yogurt is disgusting. But coming from a guy who will drink magnesium sulfate when he, you know, feels like getting flavor, yogurt is very unpleasant. And I was in a class once where the woman in front of me was eating plain yogurt, and I was just trying not to vomit. I'm just like, oh, the smell, the horrible smell. Oh, the smell, the horrible smell. Save some of that in case I need to do more. And I'm like, well, you can't exactly tell somebody, hey, your food that you're eating in the middle of class for some reason is super disgusting. Could you not do that? Because I don't want to be rude. It's not that I'm not confrontational. It's that that's not a grievance large enough to warrant a confrontation. That's just my own problem, my own weakness. Anyway, the reason I talk about that is because the yogurt that had the stuff in it, I remember it was called mix-ins, because you mix in. They made like a kid's version that had like sprinkles. Why would you want to put sprinkles in yogurt? It's already... I mean, it's not the worst smell. It's just so unexpected. It smells like cement. But cement does not like, you smell this, you'll say, oh, that smells like cement. It doesn't smell at all like you would expect, but it does. Like, you know it's cement. But right now you're thinking the smell of cement? That's not what it smells like. It's the weirdest thing. Oh, it smells very similar to the epoxy, actually. This is probably more hydrophilic. I don't know how well it'll mix. And anyway, this reminds me of mixing things into yogurt. Back when that was a thing. Depotlith. This also, because this is added, does substantially increase the volume of the material. Oh, it is not mixing well. The material looks like that. It's black right now because of the carbon. It's technically charcoal. I mean, it's not pure carbon. Pure carbon's kind of hard to get. Interestingly, also virtually inflammable. Well, not technically. This has probably silica fume, which is very fine silica, which you should not breathe unless you want to get silicosis. That's why the windows are open right now. It's actually because I was burning stuff. What was I talking about? Before silicosis. Yeah, diamonds are made of pure carbon and do in fact burn. No, I will not demonstrate that because I do not have enough money to buy diamonds to light them on fire. It's getting thicker. However, graphite in its purest form is very, very difficult to burn. Notably during the Chernobyl disaster, a large portion of the reactor control rods were made of graphite. When they were ejected during the steam explosion, they were found red hot on the ground but not on fire, just superheated from, the blast. They were very hot, but not burning. Which is a neat thing to consider. I'm going to add a little more of this depotlith. I considered using diatomaceous earth as a substitute for this. Diatomaceous earth is silica. It's the very tiny fossilized skeletons of microorganisms called diatoms. It collects in the ocean, and then the ocean stops being the ocean because of tectonic shift, and people end up mining it up. And it's useful for a variety of things. It has a very high surface area and complexity, so it would be good in this context for binding. The problem is, compared to this type of silica, which is just regular silica, the hardness is low because diatoms are very fragile, so they break. I mean, they're still silica, so it'll still scratch. And hardness is also a more complicated mechanical thing to talk about than you would expect initially. I'm going to add a little more carbon and a little more depotlith. Hardness is difficult to define. It can be defined, I mean, mechanically, yes. All the mechanical engineers saying, no, it's this. Yes, it can be structurally defined pretty effectively, but comparing the hardness of two given objects is not as straightforward as you would think. You could say, oh, well, diamonds are harder than steel. But if I gave you a plate of diamond, you could snap it in half with your fingers because it's very, very brittle. Like glass is harder than steel by far, because if you rub a piece of glass and a piece of steel, I mean, no marks. It doesn't damage the glass. You can try that on most glass. Steel will not scratch glass. However, if you have a big plate bit, probably the fumes. I should probably hurry. Epoxy will start to get warm when it starts to react. So until then, I can keep stirring, getting the mixins mixed in. So, a big piece of flat steel, you take sharp glass, you can score that really easily and make a mark, but you can't do it the other way around. But could you make a glass blade? Well, not really, no, it's too brittle. And there's actually a lot of steel where it's like, oh, this is the hardest type of steel, and it's too brittle to actually make a tool out of unless you back it on something else, like tool steel. I mean, cast iron is technically harder than steel. Try drilling through it. I've tried. You don't go anywhere. But you can't make a sword out of it because it's so brittle. That's kind of the weird thing. Like, iron as an element has no carbon, but steel has a little carbon, and cast iron has a lot of carbon? Okay. That looks kind of gross. Let's hope I have enough to actually make a pretty good layer in this. It's a pretty big piece, so I'm going to dump this into the mold slightly. Don't use all of it at once. very high viscosity, and it needs to get evenly throughout the entirety of the mold, including the handle. You don't want to have a weak handle, that's where your hand goes. I don't care what kind of sword you're making, plastic, bronze, steel. If the handle isn't good, it's not going to do anything. I actually have a bit of I don't know, not exactly a grievance, but hold on. The next stage is I have to take this and get my hand gooey again. And see, that hasn't hardened hardly at all. Hopefully it will harden eventually. That gets laid down right in the middle. Be sure, and this is important, that that is not touching the edge, or it will interfere with the structure of your sharpening, or our sharpening, later on. And then coat that. But yeah, it doesn't matter what kind of sword, tool, or weapon you have, the handle is one of the most important parts. If you do not have an adequate handle, then you will not have an adequate tool. Remember, if you tear someone's arms off, it's the wet end you need to beat them with. See, it's gross, kind of black colored. This one actually collected a lot of spare. That's why we mix, because there's always a little left over, so that's actually a mixture, and that will harden too. The idea now being we need to wait and wash off any that is on me, and hopefully not get any on my hands. Now it's important to note that at the moment, my shoes are completely full of fertilizer. Regardless of that, the knife structure seems to be largely complete. Time for a test with my testing finger. I don't remember which hand I use dominantly. I'm going to use this one. Not tacky in the slightest. Our sample here on aluminum. Very sturdy, not tacky. That's plastic. It's also pretty sharp, which gives me a good idea that this could easily produce a very sharp edge. Interestingly though, kind of ruining the movie magic, but I have been touching things before I filled my shoes with fertilizer. I got super sticky. The cup that we had, well, I had, you've probably been following along at home, but you're not here right now, I hope. Something's moving in here, but it's too small to be a person. Maybe a rodent, maybe a weasel. The cup that had the epoxy in it is indeed sticky, which always seems to happen. Weasels. Always seems to happen to me. The epoxy, when I mix it, gets sticky. But the epoxy with filler is not sticky in the slightest. Well, it is stuck, but it is no longer sticky. See? It's just hard black. Ugh. It's actually really, really hard. Oof. I just snapped a piece, and it is not easy to snap. It's pretty durable, so this is actually good for, whatever it is I'm doing. I'm not really remembering because it took like 2 weeks for this to harden this much. I'm going to try to remove it from the mold. As you can see, it's black, has a rough texture because it's full of bubbles, and it is embedded in cardboard, which is now very damp cardboard because I'm in a basement. The humidity here is basically estuarine. That's not the right word, but it does describe the level of moisture I'm currently experiencing. Let's see if the tape on the back can be removed. The answer is roughly no. It seems to be rejecting my efforts to remove it from the mold. Now usually I don't remove the mold from things, I eat it. Everyone says you shouldn't eat moldy food, but I say that mold is trying to steal my hard-earned food from me. I'm going to punish it with death by eating it. Although that's a different type of mold, obviously. In some countries, I don't remember which ones, it is actually spelled differently. Oh, it's sticky too. That's probably bad. I'm going to have to use an exotic method to get this out. The exotic method in question is a saw. Weirdly, it's harder to saw through cardboard than it is to saw through, saws. Oop. Actually, I did slightly on the epoxy, but it gives me the leverage I need to actually get the... Oh, it's sharp. And it's sticky. This is more challenging than I expected, but it is out. Unfortunately, the mold is sort of destroyed. I guess you could reconfigure that, but I don't really have enough epoxy or filler to do this again. I'm not entirely sure how to get the tape off. This is one of those questions that requires careful consideration. I think the best way to do it would be carefully, but I'm not a very careful person. Well, as it turns out, the tape is very hard to get off. So that warrants the use of power tools, which I was going to use anyway. So I've actually just gone a step forward even faster by incompetence, which is usually how I do everything in my life. You may notice that's very thick. You may not notice that. I don't know if you've ever looked at a knife, but a knife is very rarely a ½ inch thick. Very rarely an inch thick. Even like a broadsword is not that thick. The problem here being we're not working with steel, so it does need to be somewhat thicker. However, just because of the way casting goes, there is a ridge, a sharp ridge around the edge. So what I need to do is, one, file that down, and at the same time I can file it so that there is, I hope I can file and sand off the tape. I don't know if that'll work, but it's worth a shot, isn't it? Always important. Metal is especially bad with these because it tends to spark and it gets in your eyes. I don't know what epoxy will do. Also, be very careful. In fact, I probably should roll up my sleeves. It is important to remember when you're working with any sort of grinder that a grinder is always looking for meat. And it will eat your meat. There's two things that references, and if you understand one, you'll understand the other very clearly. So let's see if this thing turns on. Oh, it does. All right. It stands very easily. Now, one thing I am noticing, I'm going to close those a little bit, hopefully not too much. The material has unusual porosity, which is unexpected. It's just not slowing down. It's got that rotational inertia. I learned about that in physics when I was in college, but I didn't do so well in college, so I don't know what it means. Regardless of what I know and don't know, the material is unusually porous. There were a lot of bubbles, I suppose, and like the surface is flat and black, right? But around the edges, it actually has a number of small holes. The tape also is a lot harder to remove with this, so I am going to switch over to the palm sander. What is a palm sander? It is well, you've used one, obviously. Everybody's used one of these, right? It is a device which has a motor in there that spins it around very fast. It does require safety protection. Again, sleeves back. I seem to be running into two fundamental issues. One, I only have one grit and it's fine, because sandpaper is amazingly expensive, and I don't have money. The other is it causes all of the gooiness to congeal, which is nice because it's not as sticky, but it also means there is congealed gooiness all over everything, including myself. My formerly clean white lab coat is now covered in black powder, which is why I wear the lab coat. It's so that I can put that in the wash instead of having to remove my skin and wash it. Well, I figure while I'm here and doing all of this, I might as well actually, I got the machines. I might as well try to give this an edge. Don't know how that'll go. The idea of the edge is to use the grinder, which I've usually done with metal. Metal's a lot easier, actually, because it's a lot harder. Paradoxical, but it makes sense. Metal goes slowly in the grinder, so you can go, you can just ram it in there and just do it. This goes really, really, really fast. Almost as fast as your finger would if you put your finger in that while it's on. Again, you may think, oh, I should wear gloves. Don't wear gloves when you're working with machines like this. You know what it'll do? It'll grab your glove and pull your hand straight into the machine. We don't wear gloves. We don't have long sleeves near the machine. We don't have long hair. Oh, it's disappeared. Don't know where that went. I do know where that went. I store all the used hair. Other than that, I'm going to try to sharpen it to have an edge on the blade portion. Because that's the problem, it's square on the end. So what should I do about that? I think I'm going to try to actually grind through it, like through this, to give it a shape. Should it be pointed, or should it be, I think it'll be an off-centered point, like a Bowie knife would have. I'm going to try that, and I'm going to see what it does, but I have no guarantee that that's going to work. And then I'm going to put the edge on it. Now, a thing I hadn't considered, that I should have considered, is dust. There's so much dust. I'm covered in it. I'm going to have to wash so many of my clothes, because it's not just here, it's everywhere. Good thing I'm in a basement, but it's upstairs. It's in my sink, it's in my bathroom, it's everywhere I walk, it's everywhere I touch. It's this very fine brown powder, which is a combination of epoxy, carbon, and very fine silica, which is also, silica is toxic. If you were to breathe this for long term, you'd get silicosis and your lungs die. That's a famous cause of death in people who work through heavy silica mining and don't wear respirators. So I did go get a respirator, and I wore this. As you can see, it's very dusty. It will be coming out of my nose for ages. But the knife is relatively complete. I mean, in a prototype form. Remember, this is a prototype of the knife. I've never done this before. I've always wanted to. I got dust in my nose, again, but I've always wanted... Onions? What smells like onions? I hope it's not me. I've always wanted to make a knife like this, but I never have, and I don't know the specifics of how thick does it need to be, what's the grinding style, can you make a point? It doesn't look like much, and there is blue tape. Remember, it's a prototype. Also, two things I've noticed is, one, it's somewhat flexible if you put a lot of force on it, because it is plastic. Two, the handle, because it is this way, is integrated, which is nice. You would hold it sort of like this. Wouldn't have sharpened both sides, but if you want to make a knife that isn't sharp on both sides, the handle needs to be on one side. Again, it's a prototype. Point. I tried to put a point on it, but the problem is that because the epoxy gets thin there, thin epoxy is just plastic. It's rubbery. It doesn't stick to a point. So that is pretty sharp, but I need to see if it's sharp enough to do some damage. Not to a person, but I've got this very old sweet potato. And I am going to cut it. I probably should not have done this with a sweet potato I was intending to eat. I mean, yeah, it does damage to it. It can cut it to a degree. I'd say it's about as sturdy. Oh, yeah, it does. It damages the material quite a bit. So, it does cut, but it's not very good. The primary reason being it's very thick. I need to make it thinner in the future. Also, it does have another issue in that if you were to make an epoxy weapon, don't use it as a weapon. You could probably, like, this is not a great weapon. You're not going to be able to do much. You could probably cut someone, but not very well. It would have to be modified, and I may do another one of these episodes where I do a better version. I like doing that. I know it's not what people really want to see on this channel, but I like doing a prototype and saying, well, that didn't work well. Let me try a different way. Maybe this will be in a museum someday. Do note that if you do make this, don't take it through a metal detector and don't take it on an airplane. It won't show up on x-rays, so if you get caught with something like this in a place where you're not supposed to have any knives, you'll get in big trouble. Don't do it. I'm going to go, yeah, I'm probably going to have to recycle this particular sweet potato. I think, other than making this massive dusty mess, and a knife that sort of partially functions and may serve as the backbone for a future knife or a future similar structure, I consider this a relatively, it was a fun exercise. I enjoyed doing this. And don't breathe the dust, you'll get silicosis. I think that's all. So this is actually the conclusion of the video. You don't need to like or subscribe. It doesn't actually matter that much because nobody watches these anyway. I don't get paid, so I don't care. I just do this for the lulz. Extra.